Hi, it's time for another math easy solution. Here to discuss further into trigonometric integrals, and now look at example 6 of the example series. And I'll go over this example, which states find the integral of tan to the power of 5 times by secant to the power of 7x dx. Now this example, it doesn't look too straightforward to solve this, but we could try what we did in my last video on solving a similar integral, but in that case we separated a single secant squared of x factor. But if we were to convert, let's say, secant to the power of 7 into, we'll remove one of these out of there, secant squared of x, then we're going to be left with a secant to the power of 5 of x. And now this is hard to convert into tan, so this is not helpful. So the better way of solving this one is actually separating this in to include a tan x secant x factor. So for example here, if we were to rearrange this out, and so this is 7x dx, if we were to write this out as integral from tan to the power of 4, so remove a power from both, secant, now we'll remove this 6, so now we have even on both sides, and also we're going to get a tan x secant x dx factor right here. And now the reason we have this is because the derivative of secant is going to be tan x secant x, and we'll use that in substitution rules soon. And now what we're going to do is basically replace this tan to the power of 4 and write this as a secant x, and yeah, in terms of secant of x. So this would be integral, we'll write this out into a square, because we have an identity that can convert the square of tan into the square of secant. So now we'll have the secant 6x tan x secant x dx. And now we apply this trig identity, which is tan squared of x equals to secant squared minus 1. So we apply that one, and then we're going to get, basically, this is going to be equal to integral from tan, actually no, tan is gone, so now we're having a secant squared x minus 1 squared secant 6 tan x secant x dx. So now that we have all this, we have this term and we have no other remaining tan terms, so now we could use substitution rule and let u equals to secant of x. And the reason for this is that the differential du is going to equal to, just going to be tan x secant x dx. And now this entire term replaces this entire term there. So put this all together, we get basically tan to the power of 5 of x times by secant power of 7 of x equals to integral from u, this is u squared, minus 1 squared u6 du. So now we've completely removed it, dealing with a simple u factor, and there's no trig at all in this function. So now we could expand this out, so this would be equal to u to the power of 4 minus u squared times negative 1. That's just going to be negative u squared. Do that twice because we're having negative 1 times u squared. We get 2 u squared. Now negative 1 times negative 1, that's a plus 1. And now we have, there's an integral here, so now we have to times it by u to the power of 6 du. This equals 2, multiply this inside. This is going to be integral of u to the 10 minus 2 u to the 8, this adds up the powers, plus u6 all du. And now we just take the integral of this, so this would just be 1 over 11 u to the power of 11 minus 2 over 9 u to the power of 9 plus 1 over 7 u to the power of 7 plus the constant c. And now we can just plug in our u, which is equal to secant of x. So secant power of 11 minus 2 over 9 times by secant power of 9, power of 9 of x plus 1 over 7 secant power of 7 of x plus c. And now this is our final answer. Circle this a bit better. And yeah, that's pretty much it. Yeah, and basically that's all for today. It's all for this example. It's pretty straightforward once you start trying to figure out what you need to separate and how you're going to apply substitution rule. But usually whenever you have an odd powers for like this, you should try to separate tan x secant x. Anyways, that's all for today. Hopefully you learned from this video. Like always, you could download these exact notes in the link below. And thanks for watching, and stay tuned for another Math Easy solution.